last video where it was quite easy, so I thought I would tackle a hard one, so that I'm no longer as confident. So here it talks about the set 1 through n has unique combinations, or permutations, sorry. And n factorial is pretty big, actually. So I don't know if I could just use recursion. Actually, I mean, it's probably not that bad. This is 120, and the worst case for this is 10e4 or 10,000. So it's actually not a big number. Anyway, I guess when I think permutations, the only way I know how to do anything with it is recursion. So yeah, so I'll probably have some recursion of like def perm is, well, n and k are going to be visible in the scope. Digits. Meaning I'll probably pass an array and not a string out, but I will return a string. So for example, if I start at like 1, I would have like a 1. Yeah. And then so each layer 1s would see something like this, but then this would recurse and then call something like 1, and then I'll try to tack on, 2, 3, 4, 5, 6. Up to n. And then this stack, at the end of the stack, if the length of digits is gonna be n, then I need to check. I do this. I need to check if count equals k. If count equals k, then yeah. The number of digits is how many, it's how many you have. So if count is k, then you're at the kth permutation, and if you're at the kth permutation, update the answer to digits. And it would just be a global variable. And this is an array, so then you want to return digits is this. You want to join your answer and convert to a string. Okay, so that's the base case, else, and update global variable count. That's the base case. So for I in range of 1 to n, inclusive to n, go ahead, call perm of digits plus I if one thing that's neat with this is it's 1 through n, so you don't have to do like, you don't have to do something like that. 1 through n are unique numbers, so you can just say if I not in digits, I think, then you just call this don't you? Yeah. So at base depth, let's say n is 4, and you have 1, 2, 3, 4, because you pushed a 4 in here, then that means this layer's digits has 1, 2, 3. Because if I have 1, 2, 3, well, nothing, then I start at 1, and I do 1, and then we're left biased, so then we'll just skip 1, do 2, and then we'll do 3. Let's run it for a little bit. Oh, I guess. You can't modify it like that. But you can see n. Is it because if I modify it, I can't modify the... That doesn't make sense. I don't think this will work, but I was hoping I use global variables. Or does it need to be down here? I was hoping not to, but then what about answer? I was just hoping to update. This doesn't answer anything. Yeah, this doesn't actually answer vote down. Fine. Count in lane recursion, not it is a scope variable. Interesting. All right, let's try that. I mean, I guess it doesn't hurt to pass the answer in, but you could pass the answer in, but yeah. Anyway, okay, so at least that now compiles, and that's good. So let's run through this. So if we have 1, so length of digits is not going to equal to n if it's 3, right? So for I not in digits, digits plus 1. So then you have a 1, and then 2, 3, hopefully. Y 1, 2, and then 1, 3. What is n? Length of digits is n. Why doesn't 1, 2, 3 come out before 1, 3? And also, why does it... So 1, and then the second time around 1, 2, and I guess I want to do it before the call so I can see it before it returns. Equals digits. Python really makes some problems very inconvenient. So it looks like the bulk of it is working. It's this global bookkeeping. Okay, so the count isn't getting updated. I see. I need to pass the count back up the tree. So I feel like if it's an interview, I would just do global count. Just to save time. Like, it's recursion with global is like a lot neater because then you don't have to because you could do like count equals this one, or like you know, like you can return the count and then basically on your layer 2 now your count will be updated to 2, and then you call another one, and then that's like 2 and then 3 and then 4. So each time you bounce back up to level 2 meaning there's 2 indices, you go ahead and just have that updated count. But the thing is, this isn't necessary because it's like you're not changing information in each node. So it really is a global variable where it's, I just want it for the answer. So if my stack somehow reaches a count of X, I want to be able to get there. But let's see if the count even updates, because it's my first time using global. And now I need to erase this. Does global not? Yeah, this is more of a language limitation than an algorithmic understanding limitation at this point, which maybe needs to be here. Because I guess I have some scripts that does do but I guess my scripts are not class. So Oh, I see. I got it. I gotcha. I gotcha. All right. Can I do string? What? Yeah. This is more like syntactics. All right, whatever. For I in range length of answer I equals string of answer I. Okay, maybe let's not make it super verbose. Nervous. Let's see why. Huh? What? What is going on? I run the same test, outputs 1, 3, 2, 4, but here I didn't change anything and it gives the right answer. All right, I'll try to submit this one more time. Because it's not really possible to debug if it's outputting the correct answer, unless it ran out of stack space or something. But then in that case, it's, yeah, like, but if I copy this input, I will go ahead, look at this, and then I'll actually do 2, 3, and 4. So it looks like a stack space limitation. Let's see a discussion if there is no, oh, this is actually just using math to do it. So he's saying that if you have, so this is 3 factorial, or yeah, or n minus 1 factorial, where you increment the top bit, and then I guess you increment the, so you can kind of say, well, if k is some number, then you can do, like if it's in this bucket, then you know it's 1, and then, yeah. So basically you say, well, I know what n minus 1 factorial is if k is, so it's a modulo of that, or not modulo, the quotient of that, if the k is like, you know, like, the seal of the quotient, basically. So if it's like you divide n minus factorial and then k is like 2.5, then you go here, and then then your first digit is 3, and then you go ahead and then do n minus 2 factorial. Oh, and then you need to subtract, obviously 2 times n minus 1 factorial with k, and then 2 minus 2 factorial, and you compare it against that subtracted k, and then you kind of, I guess, search for all the digits. What's this saying? Burst into tears, blah, 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 blah. right. Yeah, so this is the minusing of the, I guess, k, but they call it L here. This is the index of, you know, just doing this one, and then I guess somewhere they would append the index somewhere, dot append num dot remove index. I guess num is 1 through 9 or something. Yeah. So, yeah, I guess as soon as I saw this, it's like pretty straightforward. Anyway, okay, yeah, I mean, I guess brute force better than nothing. I'm curious about the submissions or like the pass rate on this one. But anyway, yeah, that's it for this video. I guess there's kind of multiple ways to solve this, and both are correct. But the using n factorial as a hint to go in is like pretty neat. Probably a quicker implementation as well.